Good evening and welcome everybody. This is Obi-Wan Pez for Simplex Pachinko. We are doing some math tonight, so if you have any questions, feel free to drop them in chat. We can also work on some stuff from one of my various books that we have here, and we could really do just about anything we feel like. Grab some of the stuff off of Discord. Right, so last week we were working on this one right here. This was from Introduction to Partial Differential Equations with Applications by Zakmanoglu and Thol. This was specifically looking at kind of the early chapters where we're talking mostly about vector calculus. So in this case, this is proving that our Nabla operator, Nabla operator is a linear operator. So should really just hang up and start over. Oh man. I've been doing the accounts for my kid's school parent group, so I've got like stuff all over the house now. All right. I don't actually remember where we were exactly here, but now this may have been my attempt to say what we really want is this, that our Nabla is essentially, I don't want to say distributable because that's not quite what we're doing, but respects a distributive-like property, where we're going to give the grad operator or the Nabla operator to each of the things within an addition. So we also want to do this. Now, while we were doing this, we were assuming that f and g were functions of... I don't think it matters, does it? Be literally any functions of any size with any amount of stuff in them. I think that is the point. Okay, both f and g have x and y and z in them. So... Did I define it? No, it was a mistake. Alright, so just keep in mind, right, each of these things individually
Finally tired of all the standby. Never said that I was perfect, but I'm willing to try. Let me show you what I'm made of. I am so much more than my mistakes. And I'm finally tired of all the standing by. Never said that I was perfect.
and these are going to be general functions, so we don't know what specifically they contain. So that's going to be kind of the point, right? The grad of f times g is going to be partial of f times g over partial of x, comma, partial of f times g over partial y, partial f times g over partial z. Alright, so taking that, we could say that the partial of f times g, both of them possibly have some sort of x component to it, so we've got to consider both of those possibilities. If that's the case, we're going to say that this is going to be the partial of f with respect to x times g plus g times... no. f times, there we go, partial of g with respect to x, comma, and then this is just going to repeat, so partial of f with respect to y times g plus f times partial of g with respect to y, comma, partial of f with respect to z times t g plus partial, stay consistent, f times partial g with respect to z.
Just download and take your tracks anywhere your internet can go. Enjoy 3.
So since these are literally the same thing for all three of these, then what we have here is right, these could be separated out as two separate pieces. Partial f with respect to x, whatever, it's fine, comma, partial f with respect to y times g, comma, partial f, hey Machine Rex, how's it going, with respect to z times g, plus, and then now it's just the same thing, but with f's times the partials of g with respect to each of the variables. Hey Rex, if you're interested in doing anything, let me know, because I don't have anybody who's actually interested in this. At least not live. So in each of these cases we've got g multiplied by each of those partials, and again, if we're just separating it out as three separate vectors, or vector components, then we can bring it all back together and say that, well, this is just grad of f times g plus f times grad of g. And again, we could just manipulate that around to the way we want it. So f times grad g plus g times grad f. Woo! Yep, well, we got partial differential equations, and currently we're doing vector calculus portion of it, so... At this exact moment in time, yes. Hey, more people. Hey everybody, my name is Obi-Wan Piz, and this is N-Simplex Pachinko. We are working on really any sort of math that you're interested in, so if you have any questions, feel free to drop in chat. We'll also look a bit at Discord once we get over there. I think they've all been answered, actually, in pens. Yes. Followed by something I don't understand. Algebraic topology. Cool. Oh, nice. Yeah, I don't understand algebraic topology. So, if anyone has any particular questions, queries, concerns, interest in figuring out some math that they don't know, or, well, thank you, Rex, and good segue here. These are, in fact, the Math Chads. Oh no, is our bot down? Enigma! Yeah, it appears the bot's down. Oh well. It's dollar sign, yeah? Yeah. Set. Nope. That's alright. Enigma is probably doing something else or had some downtime, so no worries there. So, anyone who is interested, we have many other math streamers that we've been working with, and actually I'm kind of surprised nobody else is on tonight. Yep, most of them are in the United States and Canada, so they're about 5 hours behind me, and let's see, it is almost 5 p.m. for them, so some of them might be coming on pretty soon. Others will be waiting until 9 or 10 o'clock, I think. Hey, Syntax, how's it going? All right. No, don't do that. There we go. Okay, so typically, we represent curves in R3. In a couple of ways. One is going to be parameterization in R vector is equal to some sort of f of t vector. And so f of t is going to look something like little f1 of t, comma, little f2 of t, comma, little f3 of t. As long as t is on some real interval, where we have, you know, time. So it's not really that surprising. Alright, so t belongs to some interval. What? Can I ask what in the hell that is?
Can I break this hole from you? It would mean everything to me if I do. Tired of hearing excuses you're making. Future is set, it is mine for the taking.
Elon Musk is somehow a communist? Good luck with that one. Not unless he starts actually paying the correct amount of tax. Or starts pushing for every dollar over 5 million that you earn being taxed at like a 99.99999% interest or tax rate. Yeah. it's amusing that you think he would share. Also, given how he's politically aligned this cycle, yeah, not gonna happen. Or shown himself to be aligned, I suppose. Alright, so we can assume that, for instance, our, we look super cute, each of these individual functions can then be broken down further into x is f1 of t, y is f2 of t, z is f3 of t, Again, t belongs to the interval, but we already know that because our domain here is going to be that same t that we've just been carrying along the whole way. So I don't need to rewrite it. It's all good. We're going to assume that the functions f1, f2, f3 belong to complex 1. No. What is C? It is a curve, but that's not the right C. It might be complex 1, in which case, oh, there we go. Ah. Be a function in the class C1. Okay. So it's of C1. C1, come on. Where is it? There we go. Let f be a function defined in set A. Suppose that f and all of its partial derivatives of order less than or equal to k are continuous in a subset B of A. Then f is to be said of the class C superscript k in B. So C superscript k says that we have all partial derivatives less than or equal to, in this case, 1, are continuous. Now, it's not saying anything about higher class or higher partial derivatives. So we could end up having as many partial derivatives as we want that are continuous, but we can only guarantee that the first derivative on all of its partials is going to be continuous. Hey, Megalomorph. yeah, good luck with that one, huh? Good evening, I hope you're doing well. Or, well as can be expected, I suppose. Should have been here a minute ago. It's always fun. Let's see, you're 6 back, so that's what, 1600? Yeah, okay. That was always kind of a late day for me, because I was the one picking up the kids. But least in the last, like, year or two of me teaching.
And you know how to forget all the wrongs and every reason.
Alright, so we can represent the curves in R3 in a couple of ways. One is parameterization in R. So this is essentially...
It's getting me in trouble, baby. And
I was thinking, oh yeah, radius, but no, it's not. This is just standard rectangular, there we go, rectangular coordinates. I'm okay. Alright, so for the particular interval that we're talking about,
take it easy, take it slow. Ended up just like before.
we assume that the representation of rectangular coordinates can be represented like x, y, z, right? And f1 of x, comma f2 of y, comma f3 of z is going to get us no, that's not what I meant. No. R is equal to f. So here, f, right, it's on the next line. X is equal to f1, y is equal to f2, and z is equal to f3. So then we get f, our vector is going to be the rectangular representation of those things. We can call it x, y, z, we can call it f1, f2, f3, whatever we feel like. As long as this only has, or at minimum, has the class 1 representation, so we can take one of its partial derivatives, or one of all of its partial derivatives, and it is still continuous everywhere in that interval. And we have no place where if we take the derivative, we get all zeros. So this is also saying no singular points. Alright, so for each, it says for each t belonging to that interval, the non-vanishing vector dr dt, which is df dt, which is df1 dx, comma df2 dy. Oh, there's no x, it's t's. Comma df3 dt. Is tangent to our curve C at the point f1 of t, f2 of, nope, f2 of t, comma f3 of t. As long as, right, on. That's kind of redundant, but whatever, it's fine. Always got to be a little bit strict when we're specifically saying things, just to make sure we really understand it and aren't making any room for misinterpretation.
Here we go.
checking. Nope. Alright. So this says let's use this to represent a... Well, let's get an example for this.
Invincible.
Oh, you're referring to his profile picture. Okay, jeez. Woo! Okay. Here I am, just not paying attention. Alright, so let's assume that we're going to pick a particular point. So, let t equal, let t equal pi over 4, so our point now x, y, z, which is our vector at pi over 4 is going to be sine of pi over 4 is going to be root 2 over 2, comma, not a vector, it's a point. Oh man. Yeah, can't really do that. So it's not really r prime, right? Or r vector. That's for later. Right, this is also root 2 over 2, comma, negative pi over 4. Or what basis? So this is just an individual point. The equation, right, x equals sine of t, system of equations, y equals cosine of t, and z equals negative t is going to get us a particular function which, if we started at 0, for example, our x value would be 0. So if we assume essentially this is x, this is y, and this is z in the positive direction. Right? Our standard unit circle is where x is equal to cosine t, y is equal to sine of t, and z is equal to 0. Right, that just gets us this circle here. What we've got now is x equals sine of t, so our x value is going to be 0, our y value cosine of t. No, we're at pi over 4. No, hang on, sorry. At 0, because I want to get the function itself. Function, wink wink, nudge nudge. So we plug in 0 for all this, our x value is 0, our y value is 1. Alright, just go like this for now. Something like that. Okay. At 0, we're here. At pi over 2, this is going to increase our x value to 1. So we're going to get something that goes this way. Y value is 0. And our z value is negative pi over 2. So pi over 2 is 1.57. It's like here. So we've got something that needs to be out there by the time it makes a circular arc in the xy direction. And it's going that way. For you, what is that? That's clockwise. Something like that. So that's moving clockwise and downward. By the time it reaches pi, right? That's where we get our x being 0 again, yeah. So it's gonna be like, I don't know, here-ish. And then that's gonna continue going along that arc so that it hits wherever it's gonna hit down that way, and then it's gonna make it down to here-ish. At 2 pi. Obviously this is, yeah, it's too short. It's 2, that's 4, that's 6.2. It's like here. That one's also too short. Oh no, wait. That's this. So something like that. So our point here,
Calling all dunkers. What's a brew without a biscuit?
that was pi over 4,
But this is no dunk
so that's like
to go
here.
after chance.
Root 2 over 2, root 2 over 2 by negative pi over 4. Negative pi over 4 is negative 0.7-ish, so we're more like there. It's not 100% perfect. And I mean, this is
Vegas. Play. It's why we're here. 18 plus begambleaware.org.
This is like wherever it ends up fitting. Right, some in the X direction, some in the Y direction, and we're down pretty far there. Those are supposed to be the same same distance as well, so you know. This is fine. Anyway, so the vector, the tangent vector to this is going to be like that way. Something was dancing on my screen over there. It's so weird. Can't tell if it was just like hallucination on the corner of my eyes, or if it was actually like, you know, the little favorite thing is like blinking or something. I don't know. It's all good. Alright, so our tangent vector we determined from above is going to be df1 dt at we'll call it t1 comma, right, vector df2 dt at t1 comma df3 with respect to t at t1. So for this one we say, well, df1 dt is going to be dx dt. So that's going to be cosine at t1, comma. This is going to be a negative sine at t1, right, derivative of cosine of t. And then comma df3 dt is just going to be negative 1 always. So, and that makes sense, because no matter what direction we're pointing on the spiral in terms of our tangent vector, right, it's always going to hold the same downward angle as it's spiraling all the way around this helix. So if we did this like actually, right? Something like that. Whoa. Make it like way thicker at the front so it gives it an illusion of 3D. Something like that. So at T1, this is going to be, this is f at T1 vector prime. You can call it that, it's all good. Is equal to that. F prime vector at T1 is equal to, right? Then our cosine at T1 was pi over 4, so that's going to be again root 2 over 2. So it's still coming in this x direction with a component of root 2 over 2. The sine of pi over 4 is also going to be root 2 over 2, but now it's negative. So it's going to be coming forward toward our camera. And then comma negative 1. Alrighty. So another representation of this is instead going to be that this is the intersection of two surfaces. Let f1 of xyz be equal to c1, f2 of xyz be equal to c2, be some real valued functions of class C1 in domain omega belonging to R3. And suppose that grad F1 and grad F2 are not going to be the zero vector. So do not vanish is the wording that they usually use here. What year is this one from? Purdue University, 1976. So the points x, y, z that satisfy each of the equations f1 and f2 are going to make the surface. We're going to assume intersection is not empty, so that it can't actually exist, so therefore we don't have to worry about it like literally just not existing, because that wouldn't be cool. It would be a very boring example to use. Okay. So if we further assume grad f1 and grad f2 are not collinear at any point, I have questions. They make vectors. Right. Okay. Okay. So if we had two separate surfaces, and they ended up being collinear, or if the their gradients at any particular point was actually collinear, then they would have exactly the same value. They would have exactly the same vector at that one point. I think that that means that, like, the intersection of... It doesn't have to be. Right, so we take, like, two different parabolic surfaces, and we have them meet up at a particular point. At that particular point, if they're their gradients can't be equal to each other. Well, not with those particular shapes anyway. If they matched a particular shape for some period of time or whatever, they could still bend away from each other after that point. That's the problem with it. And the intersection, if not empty, of those two surfaces is given by each of the equations. Given by the equations. 3.5 is always a curve. And the assumption can be expressed in terms of the cross product. Say that our gradient F1, nice try. Gradient F1 cross gradient F2 is not 0. The 0 vector. For all x, y, z in omega. Can't draw an omega to save my life. We proved the above assertion by showing that under the assumptions that we were made, if x0, y0, z0 is any point in omega satisfying both equations, then near x0, y0, z0, the set of points x, y, z satisfying 3.5 can be described parametrically by the equations of the form 3, 2. It's x, y, z is equal to f1, f2, f3. Okay. Since gradient f1 cross gradient f2 is equal to the following. Oh, I forgot to put water in my coffee. So usually I rinse off the bottom of the AeroPress thing that I've got. Like just kind of rinse off the coffee that's stuck in the filter. Yeah, I forgot to do that tonight, so it's quite strong. I like it. Okay, so grad F1
Let your
cross
playlist
grad
shine.
F2
With Spotify
is
Premium,
equal to.
listen to your music without hearing ad breaks and keep moving to non-stop jams. Get 3 free months right now.
Right,
and
partial
cancel anytime. Tap the button
F1
to
comma
learn more.
F2 with respect to y commas. I don't like this notation. Comma.
You've been talking about patience, hoping for everlasting. You're known for talking crazy.
Okay, let's re-look up.
You know I feel inside. You know what is real and I rock with your vibe. But I don't think that we should tie. Oh no, for real. I know your deal. So please set me free. Just let me be. I know for real. I know.
Cross product is A times B. Okay, A cross B is equal to norm A, norm B. It's not norm. It's yeah, magnitude, right. Magnitude A times magnitude B times sine of theta times n, which is the unit vector perpendicular to the plane containing A and B at the same time.
Just let me be.
Okay, so they do define what this means in the next paragraph, but nonetheless. Ads are going to start in a couple minutes here, so we're going to try to figure this out quick-ish.
You're kind of too strong on your feet. I can't say that I guarantee, but I know what you mean to me.
Boy. Okay, so grad. Oi. Ah. Come on. Okay, well, wait, hang on. This happened before. So this window is frozen. My mouse is not frozen. There was something I did. What did I do?
Just let me be.
There we go. Just hit escape a bunch of times. I don't know what it is, but I like hit something and it automatically freezes the entire window. I used to just kind of freak out about it and then shut down stream. But we got to figure it out now, ish. Okay, so A cross B as vectors is equal to magnitude A times magnitude B times the sine of theta, which is the angle between them, times the unit vector dotted with the unit vector that is perpendicular containing A and B. Alright. I'm going to get up and stretch in a couple minutes, but then in the meantime, we'll run ads 3 minutes and we'll be right back. So I recommend you get up and stretch and walk around, do some exercises, I don't know, figure it out. Be right back.
I'm still on my way closer to where I belong. I'm still rolling the dice, praying sometimes it don't last it long. I'm losing my faith, I'm walking away from what you knew all along. Mama told me before you leave, if there's only one thing you remember from me, child, when you're out on your own, a million miles from home, feeling the weight of the world on your shoulders. Child, don't forget who you are, don't lose your head or your heart. I'll bet my life on your stars, you'll be dancing, dancing on the moon. I'll bet my life, you'll be dancing on the moon. I'll bet my life, you'll be dancing on the moon. I'll bet my life, you'll be dancing on the moon. Dancing on the moon.
That's not what it is.
A million miles from home, feeling the weight of the world on your shoulders. Child, don't forget who you are, don't lose your head or your heart. I'll bet my life on your stars, you'll be dancing, dancing on the moon.
Lions roaring in the morning sun, searching for a longer day. People feeling like the light has just come. We must never stop the way. Yeah. Birds jumping and I hear my name, grasping into a life. Life is happy but it's so insane. We must merely make a start. Savannah, I'm coming home. Savannah, we'll never be alone. Savannah, the beauty of the world. Savannah, let's all take a roll. Savannah. Light's gonna come. The birds have just begun. We will always take a stand.
Okay, well, I don't know how exactly to deal with that, but
Let's go back to when we were young. For the animals we stand.
grad
Let's go back to when trees were
F1,
swung.
grad F2.
Kids across the land.
They're equal to
Savannah. I'm coming
yeah, okay.
home.
Has to be equal to 0 vector because all those individual things are going to be equal to 0.
The beauty of
I think.
Savannah. Let's all take a roll.
Before it was all the individual things. No, it was our whole function was equal to some constant. Now we take grad of a constant. That's going to be 0. No matter what vector we're doing it in. Alright, I think we're good.
dance floor. Yeah, I see you on the dance floor. Can you meet me on the dance floor? 'Cause I wanna dance. Cause I wanna dance. I wanna dance. I wanna dance. I wanna dance. Cause I wanna dance. I wanna dance. I wanna dance. Can you meet me on the dance floor? Dance. I wanna dance. I wanna dance. I wanna dance. Cause I wanna dance. I wanna dance. I wanna dance. I wanna dance. Cause I wanna dance. Yeah, I need you on the dance floor. Can you meet me on the dance floor? Yeah, I see you on the dance floor. Can you meet me on the dance floor? I could dance forever with you.
Right, where we're doing determinants with matrices, all of our even entries are negative. Well, even. In this case, this is a second entry. So we will end up getting a negative for that. So, specifically, right? This is saying that this is going to be the determinant of the Jacobian f1 dy partial. F1 partial z, and on the bottom, partial f2 with respect to y, partial f2 with respect to z. Comma. Right? Partial with respect to x, partial f1 with respect to y. No, with respect to other way. This one's x, this one's z. Partial f2 with respect to z, and partial f1, no, f2, also f2, with respect to x. Comma. And again, this could be the negative determinant of swapping the columns.
It's time to make your UK Visa digital. If you have a BRP card that expires on the 31st of December 2024 or a stamp or vignette sticker in your passport, you should change to an e-visa now. This means it will never be lost and
Partial
can be accessed online at
f1
any
with
time
respect
to prove
to
your right to live,
y,
work or study in
and
the
then
UK. It's free and your immigration status
partial
won't be
f2
affected.
with respect to
Find out
x,
more now
and
at
partial f2 with respect to y.
gov.uk/e-visa.
From far away they came to us with knowledge.
So partial f1 with respect to y
They changed our
times partial f2 with respect to z minus partial f2 with respect to y times partial f1 with respect to z, comma. Partial f1 with respect to z times partial f2 with respect to x minus partial f2 with respect to z partial f1 with respect to x, comma, over partial f1 with respect to x times partial f2 with respect to y minus partial f2 with respect to x times partial f1 with respect to y. We're saying that this can't be the zero vector. If anyone's new, good evening and welcome. My name is Obi-Wan Pez, and this is N Simplex Pachinko. We are working on some stuff. Doing math type stuff, so if you have any questions, please feel free and yep. Please send me something in the chat if you're interested in learning about any particular topic, or something I can research on stream real quick, or if you want to tap the 15 years worth of teaching experience that I have, anywhere from basic pre-algebra all the way up through differential equations. Some grad level work, but most of the time I haven't used that since grad school. It's been roughly 15 years. But I can at least explain some stuff, let you know my thoughts on it.
Lessons that I learned weren't always thorough, sugar-coated like a churl. Now I'm really out here on my own. Now my homies acting like I owe 'em, done extending out my arm. Made a lot of money from my poems. Been around and now they say I'm on. I can finally say I'm up now. I'm up now. 20,000 on a bus down. A bus down. I'm on my way up, going up now. Up now. And I ain't never gonna touchdown. Touchdown.
Okay.
Mine's on, I can't turn it off. Late nights and I'm turning up. Hate life, then I learn to love. Down and out, now I'm way above. I always knew I had it. Now I'm living out my dreams. Treat that money like an addict. It's a habit, I'm a fiend. Feeling that rush. Rocket ready to launch. Hands up, ready and gone. Been waiting too long. Trust on plenty, that's wrong. Old me's dead and that's gone. Thank God I'm headstrong. I don't wanna wake up in a doubt that I show 'em everything I'm about. I ain't never going out. I ain't never did it for no clout. Now I'm sitting pretty on the cloud. I'm say I'm up now. I'm up now. 20,000 on a bus down. A bus down. I'm on my way up, going up now. Up now. And I ain't never gonna touchdown. Touchdown. And I ain't never gonna.
It's been a while since I've seen your face. How you been? I'll admit I've really missed this place. Just so you know you haven't been replaced, 'cause I still think of you now like nothing has changed. And we just can't deny our hearts so good in time.
Differential
We're both so
equations.
synchronized. And we can't let them lie in between.
This is doing a initial value problem for ordinary differential equations and systems. First order ordinary differential equation is given by f of t x x prime is equal to 0. So homogeneous. So now it's derivative dx dt. Suppose that a point satisfies a given equation. Suppose further that the third derivative, assuming that's what d3 is supposed to represent here, implicit function theorem asserts that near some point we can in fact solve for x prime. Okay, so that's what we see here. The thing we're looking at. This is not the book they're referencing.
It's been a while since I've seen your face. How you been? I'll admit I've really missed this place. Just so you know you haven't been replaced, 'cause I still think of you now like nothing has changed. And we just can't deny our hearts so good in time. We're both still synchronized. Whoa. And we can't let them lie in between you and I. There's always love we hide, but it's always with you.
So if this two parameter function, yeah, two parameter family of curves C1 and C2. Grad F1 cross grad F2 is not equal to the 0 vector. And near x0, y0, z0 may parameterize or the non-zero non-zero derivative variable, and in that's what it was. Okay, the little following thing that I have over there that says what other streamers do you follow, there's like a heart with a number of streamers that are currently online, and whenever somebody comes online, it flips around and shows their icon and then flips back. That's what's been like dancing out of the corner of my eye. Something's moving. Okay. Yeah, my OB account is currently in hey, finished. My OB account's currently in mod mode, so that's one of the reasons why that particular mode has that particular thing in the corner. We're doing some partial differential equations and talking about vector calculus at the moment, but if you're at all interested in getting anything explained, please interrupt me, and I will find a good stopping point for tonight, because, I mean, people are watching me, but I don't know who's necessarily following or not following this particular material, because I don't know. This is also partially reteaching myself this material. One, I may have learned this, but I don't remember this particular section. I don't remember this particular wording. Two, this may be old wording from the 1970s that I never learned. So it's very possible that this is something that, like, our teacher never talked about because he just had a completely different way of doing it. Okay, so if, for instance, partial f1, f2 with respect to yz is not equal to 0 at x0, y0, z0. Then we may parameterize, we may parameterize y and z in terms of x by saying that we're going to let y be equal to g of x and z be equal to h of x. So they're both going to be functions of x itself. And then we again let x be some function of t. It doesn't really matter what it is, and then those all become that thing itself. So we have not used lowercase f in this particular, whatever. F of t, so then g, y is equal to g of f of t, and z is equal to h of f of t. Slope of a line, absolutely. You got it. Oop, right. That's stuff from last week. So what we're going to do for this is we're going to say that the slope is going to be the ratio of the changes in each direction that a particular thing is moving. In this case, we really only care about the two directions in the two-dimensional plane. So how far across is it going, and how far up and down is it going, and then therefore how steep is this thing. So a lot of times, right, it's just very simply known as the measure of steepness. And in this particular case, we could just say, like, it's going to be a ratio. Thank you for the follow. Sol and Sky, awesome. So in this particular case, what we've done is we've actually just agreed that the particular ratio that we care about is going to be the change in our y direction divided by our change in the x direction. Now, we could have chosen something else, right? We could have chosen that it goes the other way around, change in x over change in y. Sullen Sky, awesome. If I can ask, where, like, what level are you particularly trying to study at the moment, if any? Or where's your knowledge at? I've been teaching for roughly 15 years, and recently our family moved to the UK from Maryland in the US, so I'm not particularly working anywhere except on Twitch, and just picked up some volunteer work at my kid's school. So we're doing some interesting stuff, learning some new skills, and I've been doing the Twitch thing for almost 3 years, something like that. And Sullen Sky, when we get our bot working again, because let me just double check. Yep, nope. Once the bot gets reset, we'll be able to post all of our family of channels that we have. I think actually I can find our.
I'm not gonna lie to you kids, it's a fucking jungle out there. Keep your head on tight. Unknown brain and mind me, baby, let's do it.
Yes.
Y'all see me flying, never drop down, smoking high, I am not round, I'm not round, no denying what I got now.
Hey, Funbox.
Keep an eye out, keep it locked down.
This is the invite for our Discord called The Elements, which incorporates all of our various channels. So we'll get yeah, you can find out like all of our friends who are math streamers in that Discord. We've got our central repository there for all of our yeah, that's gonna make it easy. Anyway, man, I gotta block stuff out. Hang on. Yeah. Once you go to the Discord there, you'll get our central repository calendar, which has like when everybody is streaming who's all friends of ours. Yeah, I mean, Famish, I had to find it out myself too. Zach and Penn had been coming to my channel for like a year before I found out that both of them were streamers. I'm like, dude. Awesome. Fourier transforms, yeah. We did it actually a couple weeks ago. We did some work on Fourier transforms because I have a very large stack of books back here for all of the various subjects that I studied over the many years. Grad school. Where is it? Yeah, we did some work in grad school on don't want to tip that over. Did some work in grad school on Fourier transforms, and it was really awesome. It was one of the things that when it kind of unlocked in my brain, I was just like, that's insane. Like, you could do this for anything. And the teacher's like, well, yeah. You know, like Taylor series, basically. It was the same sort of instantaneous understanding that it's gonna be crazy. Hey, so I just got a notification that Come Together for Good is going to be basically, as long as we hook into some Twitch charity between now and December 15th, we'll get all a little nice pat on the back. So at some point, I would like to set my donations to I don't know which exact one it is, but probably Trevor Project is a perennial one that we just always connect with at some point, and there's a couple of others that are interesting. I'll see what's available on Twitch charity, hook in for that, so that we can have a donation link somewhere, if anyone is so moved. Okay, so famished. We had the slope here, right, is the measure of steepness. It's going to be a ratio, not the ratio of the value of y to the value of x, but rather the change in our y direction compared to the change in our x direction. So in order to do this, we have to have 2 points. Right? And we're going to assume that this is going to be a linear function. So what we do is we draw this in our orthogonal directions. So again, like this is our x and this is our y. Those are the positive directions for each of those. And they are orthogonal to each other, meaning that they have a right angle between them. So north-south versus east-west, etc., etc. And if we have 2 points, again, this being just x1, y1, and this one being x2, y2. Then what we want to know is how far is this, and how far is this? Right, now if x1 comma y1 is at 0, 0, this makes it super easy, right? Because how far did it go? Well, it went from 0 out to x2 and from 0 up to y2. So that change would just be what that value is. x2 comma y2, we'd put it in as our change in y, so y2, divided by our change in x, which is x2. But most of the time that's not the case. Right, so we're going to assume that x1, y1 can be any point that we want in space. Right, so if we do this as an example, we could have, let's do x1, y1 is going to be 2 comma negative 4, and x2, y2 is going to be 8 comma 7. Right, so how do you figure out how far something went? Well, if it's on a nice like grid system, you could just count. That's not too bad, right? Especially in this case. You know, we've got nice values that we're working with. They're nice and small, but it doesn't have to be, right? It could very well be in the thousands and be all sorts of weird numbers. So we want to have a nice, easy representation that's going to be able to show us, like, how do we calculate the change in these values without, right, without saying we're just going to count. Because again, what if it's like thousands of somethings apart, and then, you know, all the numbers are different from each other, so it's not like you can just count by hundreds or count by thousands. Like, it doesn't always work that way. So what we do here is we say, okay, we're going from, in the x direction, yeah, the number 2 up to the number 8. And in the y direction, we're going from the number -4 to the number +7. So then how do we do that? Right? Again, you could just count, but the easier way to do it is to do what? And this also links into another section, which I'll get to in a minute. But if you want to, you could say, like, okay, how do we find distance? What operation do we use to get distance? If, in this case, we wanted to, note, well, how do you find, if this was like a literal ruler, right? How do you find distance on a ruler? Well, you align the endpoint with your 0 value. And then you just look where this thing ended up.
Calling all dunkers. What's a brew without a biscuit, eh? But this is
So to
no
get
room
from
know
2 to
everything,
0,
so
we had to subtract 2.
keep your Mickey
So to get from
and
8 to the
pounce.
totally
One
unknown number,
Mississippi,
we also have to
two
subtract 2,
Mississippi,
which tells us that
three
we're going to measure from 0 up
Whichever
to
online
6.
casino you play with,
And that's going to be
set a
just our
deposit limit
distance.
so you don't overdunk.
Well, how do you get
Cape
6
Town
from
to the
8 and 2?
Sky Vegas.
Okay.
Play. It's why we're here. 18 plus
That's going to be 8
gambleaware.org.
minus 2.
Let your playlist shine. With Spotify Premium, listen to your music without hearing ad breaks and keep moving to non-stop jams.
And then what did those
Get
represent?
free
Well,
months
they
right now
represented
and
our
cancel anytime.
x2
Tap
and
the
our
bell to
x1
learn.
values. So x2 minus x1 is going to get us the distance between those two values. This might be a little too busy. It's all right. Right, and in the other direction, we do the same thing. So here, it's starting at -4. Well, in order to get to 0, we would need to move up to 0, and that would also move our 7 up by the same amount. So, add 4. But you could also say, okay, well, hang on. We added 4, but that's because we were moving in kind of the wrong direction, if you will. If we want to talk about it in the same way that the other one did, we did 8 minus 2, So here this could be 7 minus -4. And so here now we're again subtracting y2 minus y1. Yeah, sure, it happens to be negative. But the most important part is just that we're subtracting these two things in order to get the distance between them. So distance between two objects is the difference between them. Use subtraction. Vertical change when 2 points on a line are compared. Run is a horizontal change when 2 points on a line are compared. Yep. So what we're doing is we're breaking it down into its two components. We have a horizontal component and we have a vertical component. So you can see that in our change in x here and our change in y here. We're saying that we have this white line that's going like this diagonally. Right? And now we want to say, okay, if that line is moving diagonally, then how is it moving in either of its two component directions, in the x direction and in the y direction? If you have a slightly older TV, for example, you may have 3 component cables that go in the back, R, G, and B. That insults me to say older, because to me that was a newer TV. I'm still used to having coax. Everything is HDMI now. Nobody knows how it works. Yep. Rabbit ears. Yeah, so we use the ratio of the difference by subtraction for each of these things. And since we said do the change in y over the change in x, right, that's going to be y2 minus y1 divided by x2 minus x1. Which in this particular case, right, we actually usually call that m. So our m in this case is going to be equal to y2 minus y1 was 7 plus 4 is 11, divided by 8 minus 2 was 6. Yeah. Well, here's the thing, right? All of this vocab that we use, it's really to increase precision. Because if you change the words ever so slightly, or if you simplify it by using different words, or more encompassing words, or more exclusive words, then you could be either taking on or leaving out more than you intend. And especially with this stuff, if you end up, I mean, not this particular topic, but anything in mathematics, right? If you're missing the definition by ever so slightly, it can change the whole meaning of everything that you're doing. So in this particular case, again, keeping in mind that this is horizontal change, and this one is our vertical change. What I would recommend is also thinking about this in terms of how are you going to, yeah, doing the little triangle is absolutely necessary. Now, if I were smart, I probably would have done this as our first one of like 12 to 6. But 11 to 6 is fine. So what we've got here is a horizontal change of 6 and a vertical change of 11. Now, we're not restricted to just those particular numbers. All this is telling us is how the line moves. And my favorite way to do this is to say, keep in mind what signs these have. So the 6 on the bottom is a positive 6. The 11 on top is a positive 11. And the more important part is that their signs are the same. So this says that for every 6 that we move to the right, we will move 11 in the positive direction for y, so that's up. For every 6 we move right, we're going to move up 11. And as long as that ratio is respected, then we can change what this specifically says any individual time we want. So for instance, we could make this for every 6 we move left. We said when we're moving right, we're moving up. So our line's going to go like this, which means for every 6 we move to the left, we're going to have to move downward now in order to make it back to the line. How's that reflected in the number for m? Well, that says that here our m is going to be a negative 6 underneath a negative 11. Well, that's just 11 over 6. It's the same number, right? And again up top here, this is m equals positive 11 over positive 6, which is just 11/6. So that's fine. And then we could also change the words entirely and say for every 1 we move right, we will move 11/6 up. Right? Again, 1 is going to be in the positive direction.
What you feel? What do you feel? You feel like doing it one more time?
And the 11/6 is also in the positive direction. And again, we could make that negative in both cases too. If we wanted to make it like much bigger, we could also do for every 60. We move right. Okay, now we're moving 60 in this direction. Well, how much more is that than the original? Well, it's 10 times more. So if we go 10 times more in the horizontal direction, then we'd better, in order to make the same, same slope, in order to get to the same line, we're going to have to also go 10 times higher in the y direction. So 110, 11 times 10.
See the way I'm feeling? It just feels so good.
right? Because m in this case is equal to 110 divided by 60. Well, that's just 11/6 again. So as long as the ratio is respected, it doesn't really matter which version of that ratio we're using. You know, switch the signs on both numbers. Make it go left and down instead of up and right. Make it go up and right a much larger or much smaller number than what you have for your m's in those particular places. That's fine, as long as it is scaled. That's what really matters. So you're multiplying both your x and your y changes by the same number. Right? So linear scaling. And then we could say, what does that look like? Right? When we got our line like this, and we're saying, okay, it's this point to that point. Right, if this is 11 and this is 6, not to scale, but whatever, it's fine. Or rather, maybe our x scale is stretched out and our y scale is compressed. Doesn't matter. The important part here was we're saying, okay, based on this, if we want to go further out, like twice as far, right, then this whole distance here is going to be times 2 compared to the original, and so the vertical distance here is also going to be times 2 from the original, so that's going to get us a 22 here. If we wanted to instead make it a much smaller one, so this could be 11 over 3, and then this could be 6 over 3, which is just going to be 2. Right? We can scale this thing up or down by the same multiplier. Alright. Let me know if anything else doesn't quite make any sense. If what I said doesn't make any sense. Or if this assists your understanding.
Face to face, I found my pain beneath the lies and broken dreams. Lost the love I had in me. It tore me apart, fade away. I felt so lost, but I held on to what I had. For what it's worth, if you're feeling low, just know that you can. Yes, you can. Life in love that you hold. Rise above and let it glow. Just know that.
Alright, we'll hold it here. Gonna go cycle water. Running kind of low here. If anyone's interested in putting in an order for some sort of exercise on Redeem, I'd be willing to entertain that. We'll be back in 3 minutes. Have fun. Behave yourself. Alright, be back in 3. See you in a minute.
This one for the person who feels alone. This one for the hero who has no home. This one for the one who live for hope. Changing better days. Pick your head up, keep on fighting, living, loving. Make your mind up. If you want it, take it, fly away, soaring high above the clouds. Hear the voices calling out. All you want is love. Crash and burn, I found myself beneath the emptiness. Make your mind up. Wanting more, I let it go. Holding on to love. Breaking through, I feel alive. For once in my life, I'ma live by the one to be all I can. Let the rest just crash and burn. Let the rest just crash and burn.
Don't walk away from me. 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 Don't walk away. 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 Don't walk away. Don't walk away. Don't walk away. Don't walk away from me. Don't walk away. Don't walk away from. Here we go. Don't walk away from me. 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 Don't walk away. Don't walk away. Don't walk away.
Alright, looks like I'm doing it myself.
Don't walk away. Don't walk away from me. Don't walk away. Don't walk away. Don't walk away from me. Don't walk away.
Oh, this one's mean. It's alright. Y'all also get to see the horrible state of this room. Legos everywhere. Not to mention they tickle. Try to move them around by foot. Alright. So the way this works. These are affectionately known by our karate organization as hydrants for reasons which will become very obvious in just a second. Anybody who wants to also do this, you're going to need a space to be able to get on all fours. Yes, I did just say that. Preferably you want something that you're going to be able to reach a full extension with your leg and in probably a 2 to 3 foot space on both sides of you. So go like this, and then we lift our leg up like that and then put it down. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hold. Then you flatten out your leg so it's not like pulled like this. You basically just push your foot back in and then kick out. 1. Repeat. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then, depending on how sadistic you are, leave it out. Pull your, or push your heel out, and then go up and down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hold. Figure 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then pull back down and stretch out your glutes, because goodness, that hurts. Usually. And then we repeat the same on the right hand side. So, up first, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on hold. Round kick out, so push your toes down. 1, 2, 4, 5, 6, 8, 9, 10. Hold. Up and down. 1, 2, 3, 5, 6, 7, 8, 9, 10. Hold. Figure 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And back down. Stretch out. And it really stretches out the glutes in the back here. I guess I did also miss another one. Or if you really wanted to, you can go backward, stick your heel out, go straight back, and then come forward. That one can go a little bit, kind of multiple ways. One is that you bring it as far forward, tuck your knee as far forward as it'll come while you're staying down like that. And then, again, balance it out. I'm really like far off to the side. Good times. And one more. Because we need to practice some of the karate, otherwise we're going to forget it. We want to do a pin on 4. if I can remember it. Sudo. Yeah, that's fun. Nope, that's not it. We go open block like that. Open block like that. Ow! Sudo up. 2, 3. And that's wrong. Open, open. Sudo. Step up. Diagonal. And then this is a yeah, step out. And hang on. This is a kick. What kind of kick is it? I feel like it's not a front kick. We're not diagonal. Here, step up. Yeah, I think it goes the other way. So here we go and do a left side kick with a back fist out that way. I can never really get it up that high. And then smash. And then we step the other way. Repeat. Repeat. And then from here, we transition to a left up block and a right, basically like a throat chop, front kick. And then when we place it down, go into a back fist. Alright, this is where we turn. We're going to go this way. In a cat stance. We bring our hands like up between. This is basically like somebody's grabbing your lapel or your shoulders. So you're coming up in between and then breaking out. Ouch. And then we do a front kick followed by a jab reverse punch. Switch sides. Break, kick, jab reverse punch. Fugo Sudo. 1, 2, 3. And then from here, we grab the person's head in front of us, smash it on the knee. Do 2 Fugo Sudos and 1 to the front. That's good times. So that's Pin on 4. We do it in. You have to do that in order to get green belt, blue belt. Yeah, in order to get blue belt. So I was doing a karate. I was doing karate with an organization called Tang Sudo, which is a variant of Muda Kwan, which is a like cousin of Taekwondo and various other karates and stuff like that. So it's a good time. I do highly recommend checking out different karate organizations in your area if you are interested in martial arts. Determine what might be right for you. Me personally, I didn't really want to go to like a dojo system where basically you're trying to pay their rent and they in turn just kind of like give you a belt in order to keep you there. I wanted to do one where it's like, you know, you've actually earned the belt. So I found that Tang Sudo was very much more interested in like having people meet me and be my friend. And not just like, you know, hey, if you stay in for 2 more months, you're gonna get another belt. Like, no, you've got to put in the effort. To that end, our karate organization also was out of the Parks and Rec program that our county put on. And in Maryland, they're in Prince George, Anne Arundel, and Howard County, I think. There might be a couple others. Carroll, maybe. But the idea was that, like, you know, it's a pretty close-knit group of people, and I mean, you're gonna get to know the people best who, like, you live near. But we went with specifically, we went with the Parks and Rec division and said, we want to do, I wasn't involved in this decision. Like 40 years ago, they went with the Parks and Rec and said, hey, we want to do our karate. Will you give us space? And they were like, absolutely. Just take, like, you know, some elementary or middle school gym or cafeteria every week. And they were like, yeah, let's do that. And then over the summer, when the schools are closed, they go to the community centers. So they've been really great. Maybe I want to not play that one. Hey, Maxie Will. So this one is Algebra 1, and this is ratios, or slope. What's the definition of slope? How do we calculate slope based on individual points? If you have any particular questions or, like, subjects that you want to learn, let me know, and then we'll try and find some cool stuff that'll help you understand it a bit better. Yeah, no, if you want the derivatives, that's this one down here. This was us doing vector calculus on a helix, so something that's spiraling in 3 dimensions. This one's kind of fun, but yeah, this one's just on slope. Never really finished it, yeah. It happens. So yeah, we've got all sorts of stuff. I've taught math for 15 years at community college, and like a couple more beyond that in the public schools. I've been out for basically a year. Our family decided to move to the UK, so we're now living out in the UK. Yeah, no worries. If you have any questions, let me know. And you know, if there's any particular subject you want to learn more about, or like shore up your knowledge, because you know, maybe something was not taught particularly well for your brain, then we'll try and work it out. That was one of the big things that was always going on at my community college, was we were always encouraged to like expand our teaching repertoire in terms of like learning better ways or different ways to teach stuff, so that, you know, if you go one way and some person's like, I just don't understand what you're saying, you can change tack and say, okay, let's try it out from this other perspective. You don't like that one? All right, let's try this other one. Let's try this other one. Let's try this other one. So I've basically been like asking all of my colleagues to teach me every possible way that they know to do things, and I've just been like the repository for a lot of the stuff. Now I'm not there anymore. Absolutely, go for it. I will say, right, community college, so we're talking generally anything up to differential equations, multivariate calculus, linear algebra, matrices. Yep, let's do it. Determinant? Or just like multiplication. Systems of equations. Okay. Yep. So let's go like this. Yeah. Let's go like this. We want absolutely. So there's this museum that sells tickets for entry. Let's do $3 for kids, $10 for adults, and $6 for seniors. So then okay, so yep. I'm trying to make one up. Things because of circuits, yeah.
this is just a must. Put me in perspective, I'm the deepest in the cut. Everybody tuning in, but this is just for us now. We know I ain't ballin' yet. Hoes wanna holler, oh no, I don't call them back. Girl, let me see you hold it down, we gon' have a blast. Cause I just wanna know what you gonna do with all of that. Ain't gotta say a word, I know what's up. You can have it all, watch me rip it off. I'll admit it, you got me feeling hella love. Even when it's going down, know that we gon' live it up. Young shot caller, always been a baller. Know that you the one, I can feel it in my heart. Yeah, I won't stop charging, we going come harder. I can see you and I, way beyond the stars, girl. I can never ever find the right words, and there's no way this is real life. There's no telling you're the right girl, so I can only say that it feels right. It feels right. It feels right. It feels right.
Grar. Hang on. I think this will do it. Let's just double check here. Yep, okay. This sold 216 tickets and have $1,642 at the end of the day. The total number of adults and seniors admitted was triple that of the number of kids tickets, but just kids admitted. All right, so to formulate this one, right? If they sold 216 tickets, we're going to say that number of kids, adults, and seniors. We could use K, A, and S. We could use X, Y, and Z, whatever you feel like. We'll just use K, A, and S because it'll make things easier. We'll know which one's which. So, number of kids, number of adults, and number of seniors total that were admitted was going to be 216. All right, the total amount of money that was received is going to be another line. So the amount of money that each of the groups bring in are going to be the number of kids' tickets that are sold times the price of each one. So that's going to be our 3K plus here 10A plus 6S is going to be equal to 1642. Right, and then the total number of the seniors and adults admitted right, the number of adults plus the number of seniors was equal to triple that the number of kids tickets sold, or kids admitted. So there's a few different ways to do it. We're just going to do matrix manipulation here. So here we can subtract 3k from both sides. End up with negative 3k plus a plus s is equal to 0. So if you pull all of those together, right, this is going to be a matrix vector with KAS multiplied by a 3 by 3 matrix that has all the individual terms in it. So going across, we just have 1, 1, 1, 3, 10, 6, and negative 3, 1, 1.
It's automatic. Motion-based charging is paired with the accuracy of a
Is equal to
built to last. Meet your new watch.
216.
Bossmatic from Boss. Available now at Beaverbrooks.
1642.
I want more.
And 0.
Hi, this is Warhouse. My new album Karaoke Moon is out now.
Oh, no surprise, you took my keys. I can drive a new piece. It's simple as
So, same deal as the other one that you wrote down there, the 11x minus 3y minus 8z equals 15. There are multiple ways of solving this. So, if you need to do it by hand, then you need to do row reduced echelon form.
If you like what you hear, I'd love if you could stream it now on Spotify.
We need to get this into 100010001, and then augmented with whatever our other one's going to be. So it's not going to be 216, 1642, and 0. It's going to be whatever our answer 1, answer 2, and answer... Oh, that's KAS, right. Hang on. Augmented because... Better idea. Augmented because it's this identity matrix times KAS is equal to whatever our answer is. You're allowed a calculator, and I'm pretty sure yours does matrices, but wanted to know how to do it just in case. Yep. So, a couple of different ways, right? If you're going to use, do you have a TI? And if so, which model? And oh man. Usually the Nspires are not allowed in schools because they do the automatic algebra solvers. But nonetheless, we'll do it. Okay, so what you're going to want to do is, if you've got all this stuff, right, so you're going to go into your particular matrix window, and what you want to do is to say that this is, oh dear, online calculator if you don't have one. Wow, yeah, pretty nice. Yeah, that's not working terribly well, but alright. That's interesting. I think it's letting me turn down the contrast. I mean, it is, but it's not. Or is it just all the way down? Yeah, it is. Alright, whatever. Yep. So, finding the matrix inverse and then multiplying it is going to be the easiest way from one perspective. And, in fact, if you're trying to do, like, here's my work to see what the inverse is, and then we'll also go a couple other steps. So, yeah, that's another one. You're going to say that I've got my A matrix times this KAS. That's probably terrible. is equal to our T matrix for total. Let's not use A, because A is already a variable. C for coefficient. That works too. Okay. So the way it actually works, right? And you probably were taught this at some point, but, you know, it's helpful to remember the real reasons. So what we've got is we want to multiply on the left by C inverse such that C inverse C is going to become I, which is our identity, 3 by 3, which then is multiplied by the KAS that we had here, which is then going to be equal to C inverse times T, which is just going to be literally all the answers. Because when we multiply anything by the identity, that just gets us the original thing that we're talking about. Alright, so multiplicative inverses will yield multiplicative identities when you multiply them, the inverse by the original thing. So C times C inverse, or C inverse times C, either way you go, we're going to end up with the same thing. Now keep in mind, matrices are non-commutative. So C inverse times T is going to be not equal to T times C inverse. So like that's one of the weird things about matrices that you have to remember, especially for all this stuff. In this particular case, it won't even work because T is a 3 by 1 matrix. Let's go like this, right? This is a 3 by 3, this is a 3 by 1, this is a 3 by 1, and this is a 3 by 3. So if you remember your checks, right? We check that the middle two are the same, and once that check is done, then our solution is going to be a 3 by 1, as shown by the outer numbers. Whereas in this case, we get a 1 by 3, or 1 and 3, which are not the same as each other. So we can't even multiply these. It's not allowed. Yep. Because what happens, right? You do, let's just, you know, let's just look at this. What happens when you do this stuff, right? 1, 2, 3. That's a terrible idea. All right, let's do actual. Let's just count. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, when you multiply these things, we're going to take, for each of the rows that we're doing, we say for the first row and first column, this is going to be here. Right, first row, first column. We've got 1 times 1, 2 times 2, 3 times 3. And then we have to add all those together. So 1 times 1 plus 2 times 2 plus 3 times 3. So 9, 4, and 1 is going to be 14. Right, then we go, okay, now we need the second row, first column, will get us the second row, first column in the answer. So here, 4 by 1 plus 5 by 2 plus 6 by 3. It's 18, 10, and 4 is going to be 28, 32. Third row, first column, third row, first column. 7 by 1 plus 8 by 2 plus 9 by 3 is 27, 16, 7. It's going to be 34 plus 16 is 50. Right, so if these, I'm not saying that these are actually the correct ones, right? But if this is your, if this is your C inverse and this is your T from the example we did over there, then this is our answer. And we just got a valid matrix. But if we try to switch it around and say, okay, we've got our 1, 2, 3 like this, and then we've got our 1, 2, 3, 4, 5, 6, 7, 8, 9. We go, okay, we need the first row times the first column. Well, what are we supposed to do with that, right? Now, it gets worse if it's not just that, because this one you might be tempted to say, well, just multiply 1 by everything. It doesn't really work that way. Because, again, what if we went like this and said that now this is 4, 5, and 6 here. We're going to multiply the first row by the first column. Well, now what do you do? Because now you've got 2 elements going across and 3 going up and down. So, like, that really doesn't make any sense. It's like, how are you supposed to multiply 2 things with 3 things? It doesn't work. So in this case, right, because we have this is 3 by 2 and a 3 by 3, again, these 2 middle things don't match each other. So we're out of luck. We can't do anything with it. Right, so this particular thing, our T times C inverse, doesn't work at all. So in some cases, especially when they're not square matrices, you'll notice that, okay, well, the dimensions aren't lining up, so we can't multiply it anyway. So we just ignore it. We just say, no, that doesn't work. Obviously, this is the wrong one. If you started with a system that was actually equal, like this one, right, and then you try to do the inverse thing, and you end up with 2 non-equal dimensions, like this, then you're probably multiplying wrong. You probably just have them backwards. Right? Make sure that you're multiplying on the same side for both of these things. And here's the other thing. You cannot multiply in between 2 objects, right? If you have a block, so in this case, C times our variable matrix, you either have to multiply on the left side of all of it or on the right side of all of it. You can't split them. It doesn't work that way. You can't just say, oh, I want to multiply on the right side of C. That doesn't work. So it's got to be all the way on the left side of everything or all the way on the right side of everything. And I mean, if you want, you can always play around with it with your calculator and see like, okay, well, clearly that doesn't get me the same thing. In the case of when you have like inverses that you're working with, technically, I guess you're just going to end up with the identity anyway. It doesn't matter which way you go. But you're still just getting into the habit of doing certain things. So when you're multiplying matrices, either you're multiplying all the way on the left or all the way on the right. Don't mix it or do any weird stuff like that. Good evening and welcome. Thank you very much for the follow. Multiply to the left side of everything. Do I have to multiply on the left side of everything for the other side of the equation? Yes. 100%. Right. So I know, for instance, when you're doing equations, right, you typically get into the habit of saying like, oh, okay, well, I've got 3x equals 7. You know what, let's do a third. Right? 1/3 x equals 7. I can say, oh, I'll multiply by 3 here and I'll multiply by 3 here. Right? Like, that's completely valid. But this is because of the commutativity of numbers, of like real numbers or rational numbers, what have you. So this is valid because of multiplicative commutativity. Big words, all that doesn't really matter all that much. All that really matters is that we know that a times b is going to be equal to b times a for numbers. Aw, thank you. So this is what 15 years of teaching at a community college has given me. It's, you know, teaching to adults for the most part, in a way that they can grasp, and when they don't grasp it, like, shift focus and try to attack it from different angles all over the place. Yeah, I get that a lot with, like, that's the other thing, is that, like, you know, here, right, I've got all the time in the world. I don't have to restrict myself to, like, oh, I've only got 2 minutes. Like, no. You want to take an hour? Let's go. And also, our bot is not working, but we have a Discord for a large group of math streamers. There are at least 10 of us at this point. So please, everybody, go ahead and click on that Discord link. You can get into, it's called The Elements. It belongs to one Penn Center. He is a math teacher out of British Columbia in Canada, and invited like all of the math streamers to come over to his place and put our schedules up. So he's really cool. The rest of the people that we have there, also pretty cool. We have varying levels of expertise and teaching ability and all sorts of stuff, and we all try to like help each other succeed, because, you know, the better we can make all of this, the better all of us will do, in terms of like being able to cover different times, being able to help out different students, like just everything. So we're trying as much as we can to get like as many people helped as possible, because, you know, we really like each other, we really like the platform in general, and some other people are moving on to YouTube and stuff like that, but you know, I might eventually dual stream to YouTube as well, but I don't know what I'm doing really. Thank you so much for the follow.
Plus, you can send hands-free messages, make phone calls, even play your favorite music.
No, Zeke. Oh.
From your smart glasses. So keep your phone
Wow. I just read a chat message from somebody else's chat. That was awesome. Woo. Yeah, Zeke is somebody else that's completely off of Elite Dangerous and not on this channel at all. AP Calc BC was the only teacher. You never forget, yeah. That's the other thing, is that a lot of those teachers, like, they get the super, they either get the super upper level classes, or they get the classes where like the students absolutely have to succeed. So like the ones who are doing probably college prep, uh, like SAT level or just under, you know, Algebra 1, Algebra 2. And everybody loves teaching like honors classes, but at the same time, like they're not the ones who need help. I was always terrible at teaching students who had like, you know, attention and behavioral issues. It was one of the things that I was just terrible at. And then I moved to community college, and like everybody in the room is Algebra 1, maybe Algebra 2. And I was like, all right, let's go. And nobody had any behavioral problems, because if they did, they weren't coming to community college. And then, like, you know, I heard, there was one time I was just in, like, an office, and I hear a verbal argument going on between a teacher and a student, and I was like, that has never happened to me. Yeah, so the other thing with, like, college professors, if they're at university or like a research institution, is that they have no motivation at all to do any actual teaching. That's not their job, right? Their job is to write grant proposals to get the college money, and I hate it. Or to do their research, you know, all of the stuff that they want to do on the side. It's one of the reasons that I really liked my community college, because our job was, this is a research institution for mathematics education. So like, if you want to do any research, awesome. But you know what you have to do is attempt something cool this semester and write it down. That's it. Like, change up how you're teaching your course in some way, shape, or form. Do something different. Try to, you know, show that you're learning as a teacher. And then go back at the end of the semester and see, like, how are things going? And then at the end of the year, how did it all go? Did you learn anything this year? How are you going to change your classes going forward? And so, like, every single semester we had to come up with some little project that had to shift the way we taught, just to see how better or worse things went. I absolutely loved that particular aspect of that college. Absolutely. Go for it. Good possibility. 4 4s with a twist. All right. All right. Let's do it like that. I'm sure I have at some point. I'm guessing that was not the All Fours card game from 19th century England pubs. If you can explain it at all, that'd be great, because this is not helping. The internet is not helping. Ah, yeah, okay. Right, 4 divided by 4 is 1. Oh, and only 4 4s. Right, okay. You also need to use parentheses correctly. Just gonna be a prick about it. Anyway. Okay, you can only use 1 4 and. Okay. Floor square root square root 4. Alright. That's fair. I think Megalomorph, that might be cheating, just because now literally you can get any number you want. Alright, so if we do it 4, 5, 6, 7, 8, 9, 10. Right, that's literally 10. No functions, well that means I can't use logs. Ew.
Whatever, all this ever but you long gone, it don't matter. Ride or die, that's been the deal. The light of your back, I disappear. But if you don't play that for me, I'm out of it, I'm out of it. I lick my gun and then I'm done. I'm out of it, I'm out of it.
Factorial square root, floor ceiling. Alright. Are there any that you couldn't get? Mm-hmm. Yeah, so 10 is going to be equal to floor of square root of 5 factorial. prove you could get any number. Yeah, that... Yeah. Oh, yeah. Yeah, well, overzealous. That's 24. Square root of this 4 something. We floor it, that's 4. Well, I mean, we're back to where we started, so that doesn't help. Factorial of decimals. That could always be fun. Yeah, yeah. I mean, that's fair. You probably can't use fractions either, so 1 over something doesn't work. Literally just 1/4. Right, if we want to make it bigger, it has to be factorial. Probably not just yet. Oh. Yeah. Yeah. Ceiling. I did floor. That was ridiculous. That's 5. Factorial is going to be 120. Square root is going to be just under 11. And then floor. You can put it to 10. There we go. Might not be the same one you did, but yeah, okay. I guess it would have to be. Anyway, as we're about to start, we're going to go for 3 minutes. We'll make sure we got some water for the next bit, and get up and stretch, do all your usual other bodily things, because, you know, bodies are cool and all that. We'll be back in 3.
Dad's festive playlist, you cremating the turkey.
I'll ignore that last comment, Noah.
Here's some information you shouldn't ignore. If you're travelling by train this Christmas, between Saturday the 21st of December and Thursday the 2nd of January, there'll be significant service changes as we make improvements to the railway. Please check before you travel at nationalrail.co.uk/Christmas.
When sound waves travel through the ear, they help us connect to the world and the people around us. But hardened earwax can interfere with a sound wave's journey. Otex Express is a dual-action formula that softens hardened wax and releases oxygen to help it break down and disperse. No other eardrops are more effective than clinically proven Otex Express from the #1 selling Otex range. Be clear to hear with Otex. For verification, visit otexear.com.
Forceps. Pliers. Spanner. Mr. Johnson, I'm glad to say your dishwasher is going to make it.
Oh, that's a relief.
Got a home emergency? With British Gas Home Care, we can fix boilers, plumbing, electrics, and even kitchen appliances pronto. Search British Gas Home Care to find out more. T's and C's apply. Kitchen appliance cover sold separately. Visit britishgas.co.uk.
Every weekend is the same. I'm the one you try to claim. Yeah, I already know about your game, but I'm not the one to sit around and be played. Call me up with no shame. All your words sound the same. Yeah, I already know about your game, but I'm not the one to sit around and be played. If you come around just to play me, don't bother, cause you ain't overdue. Don't even try to convince me. Don't bother, cause now I see you through. If you come around just to play me, don't bother, cause you ain't overdue. Don't even try to convince me. Don't bother, cause now I see you through. Every now and then I think what we had was something real. Don't know why, cause I've been hurt like this, but never thought that I would fight for you this much. Don't know why, and tonight I'm not the one to be blamed, cause I ain't the one who entertains. Yeah, already know about your stupid games. Come around, come around. If you come around just to play me, don't bother, cause you ain't overdue. Don't even try to convince me. Don't bother, cause now I see you through.
Sorry, Megalomorph. Alright. So Maxwell, this is going to come down to basically the same thing as it's an equivalent this is going to come down to an equivalent problem of can we create nope, never mind. I was going to say it's going to become equivalent to can we create the prime numbers and then go from there, but that's not true. Because we can't multiply them. Yeah. So square roots are always going to make things go down, and factorials are always going to make things go up, and that's pretty much all you've got. And then the floors are going to allow you to go either up or down to the nearest integer, so be interesting. Is it cake? Megalomorph autocomplete. I mean, like, who wouldn't want it to be cake? Ended up changing some of the ideas. Try publishing it into AMS. Did you get a recommendations back? That's why I said, did it get recommendations, or just like outright rejected? Yeah. I mean, if that's the only critique they had, that's not too bad then. Yeah. Yeah, I just want to move that. Okay. Got 100 views. I mean, that's more than a lot of mine, so congratulations. Okay. If we wanted to, for instance, try and solve for the row reduced echelon form by hand, what we're trying to do is get this coefficient matrix here to become our identity matrix, and then these numbers here are going to change accordingly. The way that we're going to do that is by using row reduced echelon form and or try and get row reduced echelon form by using matrix operations. So matrix row operations allow us to add any two rows together and make any linear combination of any two rows. Realistically, we could do all three of them if we wanted, but let's not overburden ourselves. And we can multiply any particular row by any particular number we feel like, and we can swap rows at will. So what we'd like to do is that this diagonal here should be all ones, and all the items underneath them should be all zeros. Now at the moment we don't have that. We do have a 1 in the top left corner, so we're just going to leave that one where it is. We want to then clear out the 3 and the -3 underneath it. Now the best way to do this, generally speaking, is to say I'm going to take this number and I'm going to alter the 2 below it based on it. We could, in theory, also combine row 2 and row 3, as long as you're not also combining row 3 with row 2 the other way, because that would make a 2 equivalent rows, and that's a problem. So we don't want equivalent rows if there is in fact a solution. So here, just again, as a matter of, this is kind of best practice, we're going to combine 3 row 1 plus 1 row 3, and then we're going to combine -3 row 1 with row 2. Alright, when we do that, we end up getting 1, 1, 1, 216. Alright, we should get the same answer here that we do in the inverse matrices thing. So here we're going to subtract 3 from each of these numbers. That's 0, 7, and 3. we need to subtract 3 216s, which is going to be 648 from 1,642, which is going to be 994. Then we're going to add 3 to each of the numbers in the third row. So this is going to be 0 and 4 and 4. And then we're going to add 3 216s, which is again 648.
My sight gets blurry, pushing back the tears. Should take a leap of faith and face my
Okay. Here we're going to multiply 1/4 by row 3. Here we're going to take row 2 and subtract 7/3. 7/4. Jeez. I'm fine, I promise. 7/4 row 3. And row 1 minus 1/4 row 3. Realistically, I like taking it a little bit slower, just multiplying by 1/4 here, and then worrying about some of the other stuff later, but it's fine. Okay, so we get a 1 at the top. If we subtract 1/4 of row 3, that's 1/4 of 4 is 1 from the next two spots, so we get zeros. Sweet. And 1/4 of 648 is going to be 162. So 216 minus 162, yeah, is going to be 54. Cool. Okay, next two are zeros. Bottom row is just going to be 1 and 1 and 162. Next row here is going to be... Oh, no, I don't want to do that. That's fine. We'll get a 0 here. We'll change stuff up after. Linear algebra question. Do you have a good explanation for resultants of polynomials? Determinant of a matrix made out of the coefficients of two polynomials is 0 if the two polynomials share a root. I mean, I don't. I was terrible at linear algebra. Determinant of a matrix made out of the coefficients of two polynomials. Gonna have to think on that one. I think this is now -4.
I'm so afraid that you'll run out of patience.
I thought I see today. It's essentially the resultant of two quadratics, but without being phrased that way.
Sometimes I don't know if I can even change, but I'm still trying. So I'm sorry that you might have to see I'm not flawless. I promise that I'm facing my
So it's the polynomial starting with constant coefficients. Nope. Starting with the highest degree coefficient, working its way down to constant coefficient, and then zeros if there are any terms below that. And then they all just shift down by 1 And you're doing the same thing with the other polynomial, starting with highest degree coefficient going all the way to constant, and then if there are any extra spaces below, they're all 0.
This holiday season,
And then
do
shift
something for a
down
special person in your life.
similarly for that one.
Give yourself the gift of better mental health. BetterHelp Online Therapy connects you with a qualified
Does it
therapist
have to be
via
a square
phone, video,
matrix?
or live chat. It's convenient and affordable, and can be done from the comfort of your own home. Having someone to talk to is truly a gift, especially during the holidays. Tap now or visit
Yes.
BetterHelp. That's betterhelp.com
Right.
/Spotify music for 10% off your first month.
It's time to make your UK visa digital. If you have a BRP card that
Square
expires
matrix
on the
of dimension
31st
D plus E.
December
Okay.
2024, or a stamp
That's
or
cool
vignette
and
sticker in your
strange.
passport, you should change to an e-visa now. This means it will never be lost.
We're gonna
and
have
can
to
be
look at that one.
accessed online at any time to prove your right to live, work, or study in the UK. It's free, and your immigration status won't be affected.
So
Find out
here,
more
7/4 of our 4 is going to give us -7. -7 plus 3 is -4. Okay. 1/4 of 648 was 162. 162 times 7 is going to be 14, 43, and 11. So 1134 negative.
With free spins, cash, and sportsbook bets free on Paddy's Wonder Wheel. More chances to win with Paddy Power Games. One spin per player per day. Each prize
Swap.
carries individual T's and C's. Eligibility rules and T's and C's apply. 18 plus. BeGambleAware.org.
It's going to be 10054. So we have 54. What was that? K. Kids tickets. 0. And then we could also do 1/4, -1/4, row 2. Makes this a 1. And do a fourth of that one is going to be 280. Oh no. It doesn't come out. Oh wait, no. That's not the right number. I didn't add. Okay, minus 994. That's better. That's going to be 200, but we need a carry, so that's 140. Yeah, okay. -140. Clear that out. Is going to be 3. The 2 left over is 535. Seems reasonable. And this is 162. So we're going to subtract row 2 minus row 3. That'll get us our final. 0054. 010001 35. And then here 162 minus 35 is going to be 127. And I believe that was the correct set of things that I plugged in here. 54, 127, and 35. Nice. So this is what's called row reduced echelon form, I think. No S. Okay. Yeah, see. Thank you. Fair enough. or RREF. It is in the TI calculator under second, and then if you look down, x to the first, x to the negative first, the inverse key, just above that, in my case blue, in some other cases orange, yellow, whatever you have, is the matrix menu. If you hit the matrix menu, you can then edit. You'd want to do a 3x4 matrix using your matrix coefficients as the first three entries going across, and then your coefficients, no, not coefficients, the constants as the far column. So this here, 216, 1642, and 0. Once you've entered that in, you go to the matrix menu again, over to math, and then hit up, and it cycles to the bottom. And for me, it's the letter B is RREF with an open parenthesis. Then you have to go back to the matrix menu, hit enter on whatever matrix you plugged it into, and then when you hit enter, well, that didn't get me the right thing. That's weird. Alright, so 3 to, oh, no wonder. I entered it in the wrong order. Well, you all should get it properly. There we go. Now we get that. So that's showing us again the left 3, the 3x3 portion is going to be the solution. No, the left 3 is going to be our identity matrix, and then the right column is going to be our solutions. So we end up with that 1 0 0 0 1 0 0 0 1, and then the column on the far end was what we got here, 54 127 35. Or yeah, that's right. I was gonna say in mine they got changed around, but that's not actually true. So it fixed in post. So just make sure you know in what order these things are, and you'll figure it out. Righto. So, alright, let's try and look this up then. So, is there a good explanation for the resultant? If this thing is 0, then the polynomials have to share a root. Right, so what you're really looking at then, Megamorph, is does this thing here, apologies to everybody for blinding you, does the lambda I minus mu sub j have a good explanation or proof as to why that shows up? Even in my case, no, I don't have a good explanation as to why that shows up. But that's just me. least not offhand. Resultant of two polynomials with coefficients is an integral domain. In an integral domain is 0 if and only if they have a common divisor of positive degree. I don't know what integral domain is. Non-zero commutative ring in which the product of any two non-zero elements is also non-zero itself. Polynomials with coefficients in an integral domain is 0 if and only if they have a common root in an algebraically closed field. Right. Alright, so the first sentence there is looking at x minus a being a common factor or common divisor. Right. Highest possible degree that is a factor of both of the two original. Yeah. So our x minus a in both of those exists, and therefore that's the highest common factor. Also true. Do you know why / what the proof is? I guess you would have answered it if you did. With certainty, anyway. Doing determinant here, which on this actually would not be very difficult because it's going to be interesting. I have no idea where this is going to go. Oh, cool. Because if we were doing right, A0, 0, 0 through B0, 0, 0, A1, A2, AD, 0, 0. Right, A0, A1, A D minus 1, A sub D, 0, dot.
Coming for the top, this is a
This is all zeros up until I end up with nope, that's gonna this one's A sub 0 somewhere in the middle, who knows where space. a sub d minus 1, a sub d at the end. B0, B1, B2, dot, dot, dot. B sub E, 0, dot, 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 0. B E minus 1, B E 0. Zeros all the way through, down to B1 or B0, who knows where. B1 that matches up with that one. That doesn't necessarily line up.
Now they don't know what to do with me. I keep going hard like I'm in puberty. Rebellion's in my blood, there ain't no ruling me. Coming for the top, this is a mutiny.
B sub E minus 1 and B sub E.
Don't know what to do with me. Coming for the top, this is a mutiny.
Okay. Larger determinants, not terribly difficult. In this case, super easy because now there are only two terms that actually are non-zero. Granted, eventually it's going to get larger, but... Right, so... We do this. This is going to get us A0 times
Hey Spotify.
the rest of
Click
this
or tap the banner to listen to the songs you loved the most
inside
this year.
the
Your top songs of 2024 playlist presented by Spotify and our friends at Coca-Cola.
D plus E minus 1 by D plus E minus 1.
Cue
That's
up
not
the
what I want.
music that moves you and moves with you. Explore a new world of limitless offline listening with Spotify Premium. Try 3 free months now and cancel anytime. Tap the banner to learn more.
So that's going to be A0. Zeros. Now when I say easy, not literally easy, but 0. Zero. This is going to be a sub 0, a sub 1, sub d minus 1, a sub d. Skip the first B. B sub 0, B sub 1, B sub E minus 1, B sub E, down to 0. Maybe I'm just going down a rabbit hole here, but still, it's all good. 0, 0. 0 through B0, somewhere up here. Started with B sub E minus 1 and B sub E. Hey Zach, how's it going? Ahoy. Speaking of going down a rabbit hole, right? Sunil Singh was presenting at the Matic conference that I went to, and his book Chasing Rabbits is about just having fun for math's sake. You can tell I made a few notes. Yes, it is 1. I don't mean to bother you too much, Zach, but how goes the defense? Trying to keep it real positive, yep. Good way to be.
Tell me what's the point if I lose myself? Spend a couple days with nobody.
Okay, so here's an interesting bit, yeah.
If I can find you in my dreams. Oh, I'm getting tired of losing faith.
That one doesn't need B plus E. So this is going to be, if it was row 1, we would, no, yeah. Depends on what kind of term D is. I want, if D is an odd term, that it is the same as A sub 0. So then I would want the next one to be negative. So I'd leave it as D. So it's like D plus 1 minus 1. If it's an even term, then I want that row would be, or that column would be negative, which would make the next row positive, and so we just leave it like that. Alright, cool. So -1 raised to the d power times b sub 0 times that whole matrix determinant. Not actually a matrix. Times that determinant will get us this stuff. And then we could repeat with the bottom, because it only has 2 terms again. So, Megalomorph, this appears to be kind of working its way inward, where it's going to continually knock out individual terms. I think I could have started at the bottom and then just continually worked up. But this is going to mean that we have a sub 0 times a sub d times another determinant plus, again, -1 to the d minus 1, I guess, because we removed one of the things. We removed one from last time. And then we've got the a0 from this term and b sub e times a slightly different. I'm not subtracting though. Grr. In theory, it'll be over in 2 weeks. I loved Wicked. I thought it was great. So we've, my spouse and I have been to at least 2, 3 different versions. I mean, it's the same show. It's just that, you know, new people and everything. So I could have done without the final number stretched into like 7 minutes instead of the usual like 3 to 4, 5. I don't know what it actually is. Yeah. You know, if there were only some way to actually look this up. Original Broadway cast recording. Popular, Another Girl, Short Day. Oh, come on. No, that's not the. Did they remove? That is bizarre. Go straight from Popular to I'm Not That Girl to One Short Day, A Sentimental Man to Thank Goodness. That's wild. Messed my head up, man. Oop. That was not what I meant. Yeah, defying gravity. Okay. Defying gravity. Okay, this looks like the movie version, but it might be radio edited, is at 7 minutes 39 seconds. So that's like, that is long. Defying Gravity from the original Broadway cast is 5:54. Yep. Yep. So I think that the movie radio edit also removes a couple of things just because it was like, you know, it was A, it's already long enough, and B, there's some dialogue and stuff like that that they cut. Which, no problem, right? But yeah, the original comes in at 5:54, so just under 6 minutes. The film version is 7. What did I just say? 7:39, and I think the actual version on screen is closer to 9. Just because, again, there's a little bit of dialogue, there's a little bit of like showmanship kind of things that they put on the screen. You know, cool, but at the same time, I was just like, yeah, yeah. It's like watching Olympic runners getting tripped up at the start line, right? Like, it's not how that was supposed to go. Yeah, the film version. Okay, so like the whole film as a medium, I thought was brilliant. The casting was very good. So like Ariana Grande was essentially a carbon copy of the lady we saw in DC. Like, immaculate performance, almost identical to anybody we would have seen on stage, with some other little jokes and things like that that only they could have done in the movies, that, like, you know, they would never be able to make it work on stage and things like that. There are some other special effects and whatever that were really cool. Cynthia Erivo does a great job through a number of just generally things. The other thing I really liked is that the original Broadway cast, including Kristen Chenoweth and Idina Menzel, the two of them have really close vocal profiles, and at certain points both of them will like be above or below each other, and that happens in the movie too, but their vocals are far enough apart from each other, like just in terms of tone, that you don't get them confused. What did John Travolta call her? Oh goodness. I'm not even going now. I'm not going to look it up. I will check that out off stream. Like, how do you mess that up? You get handlers to tell you all of this stuff. Like, how do you mess that up? Oh. Adele Dazeem. Oh my god. There's a nod to the Broadway show, which was really cool, I thought. The guy who plays Bach actually played Joel Grey in like a movie version of Fosse, like a Bob Fosse thing, which my spouse and I both thought was kind of funny because Joel Grey was the original wizard on Broadway. So there's like some sort of weird deep connection there. Bach, the guy who plays Bach, also is, I think, because of that role, like, primarily, he's a dancer. So it really helps that, like, you know, they've got, I mean, everybody there has, like, musical theater background in some way, shape, or form. I don't think I've seen anybody who didn't have, like, extensive, you know, like, oh, I only act, I don't also dance. I mean, pretty much everybody there was a triple threat. Like, it's just amazing. What do you expect from John Toyota Corolla? Oh. Hey Silver, how's it going? Tim Cook from Apple. All right. So yeah, Megalomorph. This is... I don't really see where this is going to be able to drop out terms that end up being identical. So you're gonna get the product of a lot of coefficients. The products of the coefficients don't make the zeros. That's weird. I might just have to try the 5x5 version and see what I get. I'll probably upload it in Elements and tag you if I do manage to work it out decently well. So we'll see how it goes. But other than that, if anybody doesn't have anything else they want to chat about real quick, it is getting to be 2 o'clock in the morning here, so probably gonna head out. Oh, geez. Ad starting at 1:40. Alright, we gotta jump out of here then. So, let's see who we're following and who's online. I have not made... Thank you, Silver. I have not made homemade Yorkshire pudding now. I do have to look up a recipe for it. Volcano Doc has been on for about 2 hours. I think we'll probably go and see her if she's not entirely wrapping up. Yeah, it looks like Dr. Gold's also leaving here in a minute, probably. Alright, let's go see Volcano Duck. We're going to be back on Friday for more gamey stuff. We'll see. It's probably going to be either Astroneer or Elite Dangerous for a little bit, because Elite Dangerous has got some big stuff going on. And Astroneer, we gotta finish up that DLC. So, hope you all have a good rest of your week. Do awesome things, do math, and we'll see you in a bit. So, my name is Obi-Wan Pez, and this is Ensign Blake Spachenko. See y'all later.